Okay, hi everybody. Thank you for having me here. So my talk's going to be a little bit more technical, for good and for bad. So just so I've got some idea about who's here, how many people here work with databases in some kind of practical way in their work, whether that's configuring or writing code or running the servers? Oh, great. Okay, I've got a technical audience. Excellent. Because we're going to be talking a lot about databases and about blockchains and about the differences between them. Because one of the key problems in the blockchain field is that it happens very often that people have an idea of something that they could do on a blockchain, and they're right that they could do it on a blockchain, but they could equally well do it in a regular database. And from my perspective, those types of applications which could be done on a blockchain could be done on a regular database, but it doesn't make much difference which. You probably want to do them on a regular database because with all due respect to products like ours and like Hyperledger, regular databases have decades of work behind them, and they're more stable and more mature products. So we're going to be talking a little bit about the difference between these two types of databases and what criteria you can look at to decide whether or not a blockchain is suitable for a particular use case. So what's the problem we're looking at? And I know you've heard this before, but I want to present it in my own way. The problem is multiple organizations that need to coordinate with each other through data. Okay? And this is like generation one of how that happens in reality. Each organization has its own internal database, indicated here with a little database icon. And then these organizations send information to each other, right? And there's many, many different ways that they can do that. One of the rules of thumb I like to say for looking for good blockchain use cases is find situations in your company where people are still emailing Excel files to each other. That means possibly it's a good opportunity for a blockchain. And there's many other ways. So, we've got some well-structured ways like web services APIs, and then we've got things going by fax and by phone. There's all sorts of different ways. Information is communicated between the companies who are working with each other on some kind of process. Of course, if the companies are communicating information to each other, they also care about ensuring that they agree with each other about what the final version of that information is. And this is where the problem can arise, and this is where we talk about reconciliation and batch processes and dealing with breaks and dealing with disagreements between multiple company systems. So generation one of how companies work with each other looks something like this. This is generation two. Okay? This is the traditional solution to the problem of companies coordinating with each other. Some entity, be it one of the companies or usually some external company, is given the task of managing the central database which represents the truth. Okay? So the database sits in this central entity. And all of these other organizations, instead of communicating directly with each other, they communicate with that central entity. So they send information to that central entity to be put into the database, and then they send requests to ask it, what is the state of this database? And we see these kinds of intermediaries appearing in all sorts of industries. You've got, for example, Amadeus in the travel industry. You've got Swift in the finance industry and custodial banks in general in finance. You've got healthcare, data providers. And this is the traditional way to solve the problem. Everyone sends information to this intermediary. The intermediary has a single version of the truth, and then there's no risk of disagreement between the different parties because the different parties don't maintain their own records and think that's the truth. They ask this intermediary, tell me what the truth is. And it can work. And blockchains, if you like, one way to look at blockchains are a third approach to solving the data coordination problem. So we've looked at peer-to-peer messaging, which can be messy. We've looked at a central intermediary, and a blockchain is a third way to solve that same problem. In a blockchain, we are actually kind of going backwards because the companies are all connected to each other, their systems are all connected to each other, and they're all sending messages to each other. But now we have a process in place that makes sure that disagreements cannot occur. So how does this happen? First of all, we have transactions, which are individual events, which one or more companies sign using a private key, using a digital signature generated by a private key. These transactions are sent not only from the sender to the receiver, but they also propagate to the entire network in a peer-to-peer way. So if you think about how gossip spreads between people, in a similar kind of way, information spreads across a peer-to-peer network. Nodes are all telling each other everything they know, and everything gets to everybody very quickly. So we've got transactions, which are individual pieces of information, and then we've got blocks, which are essentially groups of transactions that are being validated or confirmed together. We need to have that secondary process because there's all sorts of reasons why just communicating individual transactions isn't enough to guarantee consensus. Some nodes might have gone down, some links might have gone down, some nodes might be coming up after the network's been running for a while. We might have a situation where one of the nodes is misbehaving and is sending conflicting information to two different places. So for all these reasons, apart from individual transactions, we also need these blocks which generate the consensus. And if you want to know what a blockchain is simply the way in which these blocks are connected to each other in order to make sure that there's a single version of the truth across the whole network. And if you notice at the top, I actually crossed out the word blockchain, because I think in a few years' time, we won't be calling these things blockchains anymore. For those of you who are familiar with how relational databases work, Probably we could call them B-trees, right? Because a B-tree is a very interesting piece of technology which makes relational databases tick. But no one calls them B-trees because that's a very technical term, and it's not interesting in terms of the end user. So I think we should probably be calling these things peer-to-peer databases or shared databases rather than calling them blockchains, because blockchain is just what happens on the inside. It's just the technical process that makes it possible. So let's talk about the differences between blockchains and centralized databases, but I want to start by talking about things that aren't the differences between central databases and blockchains. And you'll have heard many of these things being cited as unique properties of blockchains, and in my view, none of them are. So first of all, smart contracts. Smart contract is a term which has many different meanings, but the most popular meaning of a smart contract is a piece of code which executes on every single node in the blockchain to update the blockchain state. It can be useful. We have something called stored procedures, which does exactly the same for centralized databases. A stored procedure is a piece of code that lives in a centralized database and which is triggered and updates the database's state. So that's not unique. People talk about blockchains as creating append-only ledgers of information, and that's true. Blockchains are built in that way to only allow information to be added, apart from sometimes in certain circumstances. But we can do the same with a regular database, right? We can just configure our database to only allow inserts, if those of you who speak SQL, to only allow data to be added, and we've suddenly turned our centralized database into an append-only record. So that's not unique to blockchains. People talk about blockchains enabling safe exchanges of assets, so we can have a single transaction in which I pay you dollars and you pay me pounds. And that can be atomic, which means the whole thing happens in its entirety or it doesn't happen at all. And it's true that blockchains enable that, but you can do the same thing on a centralized database. We have something called transactions, which allow us to group database operations together and to ensure that either all of the operations succeed or all of them fail. So that's not unique to blockchains. People talk about blockchains being robust, and it's true they are incredibly robust as an architecture, but we have other types of technologies today, distributed databases, multi-master replication, which lets us achieve the same level of robustness in a central database. So that's not unique. Let's talk about some of the things that people say blockchains are better at compared to centralized databases, but they're actually worse, okay? So transaction immediacy. People talk about the fact that you can do a transaction immediately on a blockchain, that it happens quickly. It's true that blockchains can settle a transaction in, let's say, if we're being generous, 1 or 2 seconds. That's true, but a centralized database can settle a transaction in a split second. Those of you who know what ACID stands for, we have this word ACID, which is a series of characteristics that we expect from our databases today. The D stands for durable, and what it means is as soon as a transaction is finalized, it's committed to disk, and it is effectively settled. It has updated the state of the database in a final way. And centralized databases can do that quicker than blockchains. The reason is very natural. Blockchains have this element of consensus. Blockchains have this notion that when something happens, more than one party have to agree that that thing has happened. Centralized databases don't have to worry about consensus. So for those of you who are interested in politics, dictatorships tend to be more efficient than democracies because they don't have to ask anybody before they do anything. And it's the same in a centralized database. Scalability. People talk about blockchains being uniquely scalable. That they can be made very scalable, but nonetheless, they are less scalable than centralized databases. And the simple reason is that a blockchain node, if we're talking about one of these nodes in a blockchain, has to do everything that a centralized database has to do, plus it has to do a whole bunch more on top. Right? So it's not just that today's blockchains are slow, it's that as a technology, blockchains are inherently less scalable if we're worrying about how many transactions per second than centralized databases. And lastly, people like to think that blockchains help with the problem of confidentiality, that we want to keep data secret, and so instead of putting our data in a centralized database, we put it in a blockchain, and that somehow that increases secrecy. But again, secrecy is harder to achieve in a blockchain, and the simple reason is that the information that goes into a blockchain is replicated in multiple locations, probably in multiple organizations. So whatever we put in our centralized database before, now we're putting it not only in that one location, but also many other locations. So if blockchains aren't different from centralized databases in all the ways I showed before, and if they're worse than centralized databases in this way, then you would legitimately put a question mark on this slide and say, well, why are we all here? Why are we talking about this technology? But there is a reason why we're talking about this technology. But it's important to understand that when you're thinking about the possibility of using a blockchain, as soon as that possibility enters your mind, you should also consider the possibility of using a centralized database for the same purpose. Because in terms of the types of data you can put in a blockchain, you can do all of that in a centralized database. In terms of the types of transactions you can run over a blockchain, you can run all of those types of transactions on a centralized database, and vice versa. What we're looking at here is a technology choice. Okay? You can build a system on a centralized database, and you can build the same system on a blockchain. And like most technology choices, for those of you who've ever had to choose between technologies, you'll be familiar with the fact that there are trade-offs. Right? Advantages to one decision, advantages to another decision. So what is the central trade-off here? in this technology choice between using a blockchain and using a centralized database. So in case it's not clear by now, the key advantage of a blockchain is what's called disintermediation. It's the ability to have multiple parties sharing a single database and achieving a single view of the truth without taking any individual party and putting that party in charge of the database. That's what blockchains give us. They allow us to share database across trust boundaries, across organizations, and all of the things that databases do in terms of making sure that everything's consistent and everything happens and it's finalized, that all works even though no individual organization is in charge of that database. And that is something genuinely new compared to how databases are built today. On the other hand, the key disadvantage of blockchains, when we look at practical applications, is the problem of confidentiality, is the fact that information is spreading far, far wider. So to take the classic example of 10 organizations who have crowned a central intermediary to be in charge of their database, when 2 of those organizations conduct a transaction, who sees the transaction? The 2 organizations and the central intermediary. And the other 8 organizations have no idea it even happened. On a blockchain, because everything is getting to everybody, all of the other participants in the network see that event take place. Now, we can use all sorts of weird and wonderful and extremely clever encryption techniques to hide all sorts of different aspects of those transactions. And we can talk about ring signatures, and we can talk about confidential assets, and we can talk about zero-knowledge proofs. There's a lot out there, and it's a very deep subject, and I'd recommend getting into it in depth if you're looking at blockchain deployments. But the bottom line is blockchains are sharing more information between the peers than a centralized database is. Because even if all everyone sees is that something happened, and that's all they see, and they don't even know who did it and what happened, that's still information that they wouldn't see when there's a centralized database run by an intermediary. And that information can often be mined and leveraged for commercial reasons. So that's the key trade-off. There's other lesser trade-offs. One of the nice things about blockchains is they give us robustness across multiple organizations. So if you're a participant in a blockchain, your organization can actually have its systems go down for a week, the systems come back on again, and everything is automatically caught up. And that's a very nice disaster recovery strategy when you don't even have to rely on your own disaster recovery systems. And the disadvantage we've already talked about is performance. But when we look at actual, the use cases, when the pedal hits the metal, the trade-off that I see being absolutely crucial is the disintermediation versus confidentiality. It's as simple as that. How much do we care about one versus how much do we care about the other? So let's look at some classic use cases. And this is the absolute classic use case that people talked about. I include this in terms of what we did in our product as well. The reason this use case was the first use case was because it's rather like Bitcoin. And of course, Bitcoin and other cryptocurrencies are what started this whole conversation off. So Bitcoin is a cryptocurrency that moves across a blockchain. And so people were thinking, well, what other ways can we use blockchains to transfer assets around? And so you can use a blockchain to create an instant payment network between multiple companies, multiple financial institutions. How does this work? Each participating institution runs a node on the blockchain. They all connect to each other in a peer-to-peer way. Money in some form, it could be assets, it could be shares, it could be bonds, it could be IOUs, it could be regular cash. Something is issued onto the blockchain as a token. So you can't actually put a £5 note on a blockchain, but you can put a token on the blockchain which represents ownership of that £5 note, and then that token can move between the participants on the chain. And when we talk about this, there are a lot of people that believe that one day central banks will issue their own currency onto blockchains, as well as the current ways in which they issue currency. So they'll print money, they'll issue it to the banking system, and they'll also issue it onto some blockchains. And that may happen, although probably not in the next few years. Once we have everyone connected on a blockchain, once we have assets represented by tokens on the blockchain, then we can do instant transfers between the participants in a peer-to-peer way. People can send money to each other using these tokens exactly in the same way that people send Bitcoin to each other over the Bitcoin network. And we can do better than that. We can attach any metadata we want to these transactions. So our platform supports up to 64 megabyte of metadata per transaction. So you can put in scans of contracts, geographical imagery, anything you want, standardized Swift messages, anything you want, you can put in as metadata to those transactions. And that also gets embedded in the chain as well. Settlement happens in a matter of seconds here because the only thing required to perform a settlement if assets are moving over a blockchain in this way is for the consensus to be reached across all the nodes in the network. And in permission private enterprise blockchains, that's generally in a matter of seconds rather than certainly in the Bitcoin blockchain, a matter of minutes. Reconciliation as a requirement falls away here. There is no reconciliation. Reconciliation happens in real time, automatically as a natural byproduct of the transactions that are taking place. So the blockchain is doing the reconciliation in seconds. No one has to check afterwards, do you agree with me? No one has to do batches once a day or once a week to check that everything matches up with each other. The reconciliation is automatic and it's built in, and that's nice. And regulators look on this kind of technology with a positive approach because what they can do with this is they can essentially run a node on the blockchain themselves. This would be a read-only node, so they can't transact, but they can nonetheless see everything that's going on. And suddenly they have a real-time view of everything that's happening in this space without having to ask anyone for any extra information. So instead of having to go to all of the individual participants and ask them for reports and then cross-correlate those reports to each other and work out what happens when the things don't quite correlate, the regulators can simply have a bird's-eye view of everything that's going on. So technically speaking, this sounds fantastic. In terms of our product and other products, you can do this today. Successful pilots have been run on our product to do exactly this. So it's all done and dusted, and it's all wonderful, with one slight problem. And that problem is confidentiality. Because when you look at these types of instant payment networks, the problem is that every participant in the network can see where the money's going. Right? So they don't just see their own transactions, they see everyone else's transactions. And often what's happening in this type of network is the participants in the network are competing with each other. And if they're competing with each other, what they very much want to know is what each other are getting up to. And so if they can watch what each other are getting up to, obviously that makes it something they're going to resist joining, and it's never going to happen. So that's the key problem. And again, I should say that there are lots and lots of brilliant cryptographic techniques to partially or almost completely solve this problem. But nonetheless, this need for confidentiality in these types of networks makes them often an impractical application of blockchains. Let's talk about another type of application. Again, we have many companies here connected to a blockchain, but they're not trying to move assets with each other. Instead, they're trying to share data. So they're using the blockchain to record data. What does the blockchain give them when they're recording data? Well, first of all, in order to put anything on a blockchain, you need to digitally sign it. So each piece of data that enters the blockchain is digitally signed, and everyone knows where that piece of data came from. Second of all, every piece of data on the blockchain is timestamped. And when we talk about timestamping on a blockchain, it's not one person's opinion about what the timestamp is or one company's opinion about what the timestamp is. The network as a whole comes to consensus about the timestamping of every event, to the accuracy of a few seconds, not down to the millisecond, but to the accuracy of a few seconds. So we have the ability here, by using a blockchain, to have timestamping performed as a matter of consensus, and then there can be no dispute as to what time something happened. And then third of all, we've got its immutability. So immutability means inability to change. It's this notion of an append-only ledger. So once the information is on the blockchain, it cannot be changed. And it's important to clarify what we mean by immutability, because this isn't information that's being written into the mind of God, right? There's no like Platonic realm in which all the information is sitting and can never be touched. What we have here is information which can only be corrupted or changed if a majority of the validating nodes decide to maliciously collude. That's what we mean by immutability. So it's immutability on the level of consensus between the participants on the network. But that's pretty strong. That's certainly stronger than saying, well, we're trusting one organization to keep a record, and all it takes is for one misbehaving system administrator in that organization, and they can change the data in the database. Now we have multiple participants who are collectively ensuring that the data cannot change, and the timestamps cannot change. And this is something that's valuable. As soon as we have transactions which are not representing the movement of assets, but are rather just representing data, we can use encryption quite freely. Right? Because we can simply encrypt the data we're putting on the blockchain. We can ensure that only certain parties have the key to encrypt that piece of data. And then we kind of get the best of both worlds. Right? We have information on the blockchain. It's timestamped and it's immutable. Everyone comes to agreement about when it was placed there, and it cannot be changed. But nonetheless, the actual content of that data is only visible to certain parties. So that can give us a good trade-off. Everyone, of course, has a single view of the truth, because that's what blockchains do. And again, we can have a situation where a regulator will be very happy to watch what's going on in this kind of network. So if we're willing to use encryption to solve the problem of confidentiality, then we can look at something like this as kind of a pure gain. It's the pure ability for multiple companies to share data with each other and create a shared record of what happened, and do that without putting someone in charge, without having a central party in charge of that database. So it's a win in terms of disintermediation. I want to talk about some of the other use cases. And again, just to clarify, every single use case is about thinking, does this make sense in terms of gaining disintermediation at the cost of losing confidentiality? And we have lots and lots of projects being done on our platform, and over the last couple of years, we have a fairly good idea about where this trade-off leans positively in favor of blockchains. And this is kind of a general categorization of where that happens. First of all, if a process spans multiple companies, multiple geographies, and we want to make sure those companies all agree with each other, sometimes there's a problem that they cannot agree where this database, that would be the centralized database, they cannot agree where it's going to sit, right? If there's a manufacturer in China, it's shipped through Europe, and it ends up in a retailer in the US, well, where's the database going to sit, which keeps track of what's going with that item? And it's not just about where that database physically sits, it's also about which organization is responsible for running that database, and under which legal and regulatory regime does that organization sit. And sometimes it's not easy to find a good answer to that. because we don't want to, none of these places want to put control somewhere else. So a blockchain can be a good solution for these organizations to come together and create a peer-to-peer shared record of events without anyone being in charge of it and without them being subject to any individual legal regime. So that's one place where we see that there's a genuine value in that trade-off. There's another type of application where it's just about aggregating data between participants, and no one is even trying to hide anything from each other. So think, for example, about stocks that are traded on 20 different stock exchanges. And those stock exchanges want to aggregate together data of everything that happens. So they have a single shared record of all the trades that took place. How would they do it today? Either they're all sending copies of data to each other, so you think that's 20 organizations who are each running replicas of 20 other organizations' databases, and if you move that from 20 to 100 or 1,000 in other use cases, it becomes unwieldy. Or they take some central body, and that central body is given the task of aggregating this data and then producing the kind of aggregate version of it and sending it back onto all the participants. So this is a case where no one's trying to hide data from each other, and if that's the case, of course, the confidentiality side of the trade-off doesn't exist. And we can only enjoy the fact that we're able to create a shared record here and not have to have some individual party in charge of it. So that's a very strong use case. You heard before from John about lightweight financial systems. So it's financial systems where the stakes are low. Often that also means that the amount you're willing to invest in the system is relatively lower. So a blockchain, for these kinds of cases, is a quick and dirty financial system, right? You don't have to create an organization in charge of knowing who owns what. You don't have to worry about signing contracts with that organization. You can just have a bunch of participants together, come together and create this shared ledger to represent who owns what, and they can do it on a very cheap and peer-to-peer basis. When can we use this? We can use this in cases where confidentiality is not such an issue, where the assets that are being transacted represent a relatively small part of the financial activity of those organizations. So they're willing to show each other what they're doing. So loyalty points, gift cards, credits, all of these kind of alternative kind of financial instruments. And the last one we're seeing, and this was a genuine surprise for me, is internal blockchains within a single organization. Right now, you would naturally ask, and I naturally ask, why would we have a blockchain in a single organization? Because a single organization can just run a database in the headquarters, and everyone uses that database. Why would we need a blockchain? And the answer is that often single organizations aren't really single organizations. Often they're spread over many geographies. They've got many subsidiaries. They need to interact and transact with each other. And you often have, for example, in the finance world, you often have banks which move money between their subsidiaries through the traditional correspondent banking system. They're going through other third-party banks, and you'd think this would be a crazy thing to do, but they do it because even though they might have the same name and even though they work together closely, they are separate legal entities, and they are subject to separate regulation, and they each need to maintain control over their own assets. And the fact that some database in headquarters said this asset belongs to me isn't enough for the regulator in the geography in which I operate. So in those sorts of situations, and there's a few projects I'm aware of that are doing this, you can build an internal clearing and settlement network for the groups within a subsidiary, for the subsidiaries within a group. And again, what we gain here is the disintermediation. We can have direct peer-to-peer transacting, and often confidentiality is not such an issue in this case, because these separate entities are mainly collaborating with each other. They're certainly not competing with each other for the same customers, and so they're more willing to share information with each other and for the transaction flow to be transparent. So that's kind of a general high-level categorization of the four categories where we see this being a good technology and where the trade-off falling positively in favor of blockchains rather than central databases. As we know, this is a field which has generated a huge amount of excitement and interest and a lot of hype and a lot of hot air. And one of the ways in which this has expressed itself are platforms which are calling themselves blockchains or companies that are developing blockchain platforms, but where the key advantages of the blockchain are being lost in what they're developing. And there's a few examples of this. So one example that we see is a blockchain platform which has a single validator. In other words, although everyone's viewing all the transactions and verifying all the transactions, there's a single party which is responsible for validating every single transaction that takes place. So there's one entity which is completely in control of the database, even though everyone can see what's happening in that database. Now, I'm not going to say that this doesn't provide any value whatsoever over a centralized database, because the parties in this system do see everything going on and they can validate everything for themselves, but they haven't really gained disintermediation, right? They haven't really removed the power of a central party. So if we're thinking about blockchains as a trade-off, the value of that disintermediation has really dropped quite a lot, because there is still some central party which is in charge of the database and can decide which transactions get validated and which transactions don't. So that's one example. Another one we see is what I call a shared state blockchain. And this is where the nodes that are running the blockchain are actually just kind of a traditional database with some kind of blockchain-like features put on top. And there's a few examples of this in the market. And the reason this is a problem is that if you take a traditional distributed database, which has multiple nodes which communicate with each other and have to reach consensus, that type of database is built around the assumption that every node can fully trust what every other node tells it, right? all of the nodes are running in a single organization. The purpose of being a distributed database is to create robustness and scalability, but there isn't this issue of trust, there isn't this issue of crossing the boundaries between multiple organizations. So if you just take a traditional distributed database and throw a few things on top that look a little bit like a blockchain, you haven't gained that key ability for each node to really maintain control of its own state. And you haven't gained that key ability for it to be resilient to the misbehavior or to the malfunctioning of other nodes which are running in other organizations. And so that is also, in my view, a half-baked blockchain. And the last type is what I call a centrally hosted blockchain. So what's a centrally hosted blockchain? A centrally hosted blockchain is where a provider comes along and says, we are building a blockchain for you. All of the participants who want to use that blockchain, they all have to use our service. Right? So you can have your own node, but really we're running it for you. And you see a few offerings in the market like this. And the problem with this is, again, we're losing that disintermediation. We're going back to a model where everyone is dependent on a single provider or on a single supplier. Now, I'm not ruling out the idea of running some blockchain nodes in the cloud. You may want to run some blockchain nodes in the cloud. But you should have the choice about where you run that node, and you should be able to move over time where you run that node. And it should be possible to connect a node running under AWS with a node running under Rackspace, with a node running under Azure. That should be possible, right? That makes sense. But the idea of a blockchain platform only being accessible if you come to this centralized provider of data loses the whole benefit of this thing. And what you end up with is a situation where you'd actually be better off having this centralized provider running a centralized database instead of running a blockchain. It would be exactly the same thing, but they'd be using technology which is more mature and performs better. So lastly, I want to just talk briefly about MultiChain. So MultiChain is a popular open source blockchain platform. As I'm sure you know, there are multiple blockchain platforms out there. MultiChain is rather popular. It's been more than 2 years in development, and it's just gone into beta for the first version. The key real selling point of MultiChain is it's actually incredibly easy to use. And what we find happens in organizations is that our entrance point is simply some developers in that organization wanting to try do something on a blockchain, and they break their heads on many of the other platforms out there, and then they try our product, and very quickly they can get something up and running. So that's kind of our key selling point. We make it easy to do the most common things that people do on blockchains, which are managing permissions, moving assets around, exchanging assets, and so on, and also data streams, which are kind of what I talked about, embedding data in the blockchain and querying that data. Our model is not to work generally with the end customer, the large corporation that you might be selling a project to. We work with partners, so there's many, many companies that build solutions on our platform, and you can see some of the partners listed here. So that's the end of my talk. I'll be happy to take any questions. Thank you very much.